Okay, let's talk about selection sort. There are a lot of different sorting algorithms. They all have names that reflect the way in which they work. You might have heard of other ones like insertion sort, or bubble sort, or selection sort, or quick sort, or merge sort, or radix sort. There are a lot of different kinds of sorting algorithms that work in different ways and have different performance characteristics under different situations. Selection sort is one particular algorithm that I'd like us to take a look at. The way the selection sort works is it rearranges each of the elements in the collection so that they're sorted. Not surprisingly, it's a sorting algorithm. And the mechanism by which it does that is it goes through looking at the tail of the current array that you're trying to sort, where the tail starts with the whole array and then gets smaller and smaller. And it finds the smallest element that is in the unsorted portion of the array, and it places that at the beginning of the tail. Then it shortens the tail by one element, and it looks in the new short tail for the next smallest element. It then takes that next smallest element and puts it at the beginning of the tail. And so each time that you go through this process of looking through the tail for the smallest element and putting it at the beginning of the tail, you know that you found the smallest element from everything that has been sorted so far. So the effect of this is find the smallest element, put it at the beginning. Find the second smallest element, put it at the second spot. Find the third smallest element, put it at the third spot. Until eventually you get to the end where the tail consists of just the last position, and there's only one element there, and so it must be the smallest of just the list that contains itself, and so there's no work to be done because it's already the largest element of the whole array, but it's the smallest element of the end of the array. And you're done. Your array ends up being sorted by selection sort. This is not a particularly fast sorting algorithm. It's very slow as your data set gets larger and larger, but it's a good place to start for understanding how sorting works. So let's take a very small example of what this looks like and walk through it. Let's say we had an array with 5 elements in it, 11, 9, 17, 5, and 12. What would selection sort look like in this case? What we would do is we would start with the tail we would start by considering the entire array as our tail. And we would find that the smallest element is the element 5. Let's go back and look at what it looked like before. Move left. You can see that 5 is over there between 17 and 12, and 11 is at the far left. So we're going to look through this entire array, see that 5 is the smallest, and swap it with 11. Move right. So now, after having done one pass through our tail, which consisted of our entire array, we know that the first element has the smallest element in the array, but all the selection of our array, the tail of our array, from the second position on, are unsorted. We swapped the 5 and 11, and so we don't know anything about the light gray part. Now we proceed to look through the tail, starting at 9 and going to 12, and find the smallest element. Well, it turns out that that's at the position where it should be already, and so no swapping needs to occur. Now we know 5 and 9 are in the correct element. So we look through the tail, starting at 17 and going up to 12 to find the smallest element that remains. Now that's 11. We swap 11 and 17, and we know now that 11 is the smallest of the elements in our previous tail. We shrink our tail by 1 so that 17 and 12 are the only elements in our tail. We look for the smallest element. It's 12. We swap position 12 and 17. We anchor position 12 as being sorted, leaving us only with a tail of one element. Tail of one element, there's only one element, so it's got to be the smallest. And so we know that we're done. Our sorted array now contains the elements 5, 9, 11, 12, and 17. Good. Pretty straightforward. Move right. Selection sort, the basic idea is to pick the smallest element, like maybe the shortest Santa out of a lineup, and swap it with the first one. We're going to pick the smallest element of the remaining elements and swap that with the second one. And then we just continue that going on and on. So what I'd like to do is I'd like to give you an opportunity to reflect on this and to look at some Java code that implements it and just see if you can find your way around it and see how that work is actually done when you implement it in Java. Thank you for your attention.